Hi, I'm Emma with the Moon Society. Dr. Paul Spudis is the Principal Investigator for NASA's Planetary Geology Program and member of the President's Commission on Space. He's also Principal Investigator for the Mini-SAR experiment on the Indian Chandrayaan mission and recently has become an author of a children's book on lunar colonization.
In order to successfully go back to the moon, I think you need to understand better the environment and deposits of the lunar polar regions. What we found from Apollo was that the materials that we need to live on another world, to live on the moon, exist on the moon. They just exist in very low quantities. In some cases, things that we need, volatile elements like hydrogen, are very rare. They occur at the part per million level at the equator. But we found recently that they occur in greater quantity at the poles of the moon, because the poles are a unique environment. They have both areas of permanent sunlight and areas of permanent shadow. The permanent shadow is very cold, and because those cold areas are stable, geologically stable, they can accumulate volatile elements that are added by impacting comets and meteorites over time. So over a long period of time, you may have a significant amount of these volatile elements in the cold traps. Now, we had two missions in the 1990s that indicated that might be the case. Clementine found evidence for the possible existence of ice at the south pole of the moon in 1994. And then 4 years later, Lunar Prospector found elevated amounts of hydrogen at both poles. But that's pretty poor data. It's low in resolution and it's low in fidelity. It's low in quality. What we really need to do is to get a series of increasingly detailed data sets that tell us where this material occurs, what its physical state is, and how difficult it is to access it. So the first step is to determine what the nature of the volatile phase in the polar dark areas is. Is it present as water ice? Is it present as excess hydrogen? Or is it present as hydrated minerals? The minerals have actually bound the water in rock structures. Now, the reason that's important is because whatever phase it's in, that determines the process that you use to extract it. So determining what that phase is, where it occurs, what its concentration level is, it's a very basic problem in mining geology. It's finding out what the prospect is, finding out what its grade is, and then determining and selecting the process you're going to use to extract it. Now, once we found out where this material is and we found out what its physical state is, the next step is to actually send landers down to the surface to do in-surface assays to measure the precise physical and mineral characteristics of these things in place. Once you've found that out, then you can design demonstration experiments where you actually send small spacecraft to take small pieces of the feedstocks, dig up bits of soil, process it, and practice extracting the water and the volatile phase out of this lunar soil. Once you've done that, once you've done an end-to-end demonstration that you can land on the moon, dig up the feedstock, process it, and extract usable materials, you've taken a giant step forward to making the moon habitable.